Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Zero Trust Applications with Confidential Computing with special guest Patrick Conte, Regional Director of Americas for Fortanix. Patrick, welcome to the show.
Thanks, Darren. Really glad to be here with you. You and I are old friends, as both you and I know, but probably all of your podcast audience doesn't. We've known each other for about 7 years and have done
I know. I can't believe it's been that long.
It's been that long, and lots of interesting things in the data center space.
Yeah, I mean, we first did work together creating. You were working for another company, High Trust, I think, at the time.
High Trust, yeah.
Yeah, we worked on something for IBM Cloud. First secure virtualization stuff. It was super cool. Oh, we did such good work. Pat ourselves on the back. It was awesome. But hey, Patrick, besides that, tell my audience a little bit about yourself and your background.
Sure. Thanks. So I've been with Fortanix for most of the last 4 years. I did have a little mini professional vacation for about 18 months in between my first time at Fortanix and now, when I was leading a company that was in the AI space that was doing application optimization in the Kubernetes arena. Pretty interesting stuff. Company eventually got bought by Cisco by the App Dynamics division. And the day after that deal closed, I walked right back into my old bedroom at the old Fortanix home. So I couldn't wait to get back to cybersecurity and get back here. This is Darren, as you know, I've been in startup land for a long time. This is actually my 9th startup company, and I've exited 4 of those. I think 4 or 5 of them have been Intel Capital companies. So I've been in and around the Intel orbit professionally for quite some time. And most of the last 4 years, I've been running global business development, which meant I was responsible for all of our confidential computing engagements, as well as working very closely with Intel on, Intel SGX technology and some of the other, TDX now and some of the other groundbreaking technologies you guys have come out with in confidential computing.
Well, so we're cousins, not brothers. We're cousins.
Yeah, but it's first cousins probably.
First cousins, yeah, exactly. So that's pretty awesome. And why did you come back to security? Because AI is all the rage. So why come back to security?
Well, so security and AI are clearly crossing over. And when I left the company to go do this AI startup, one of the reasons why I went to the company's called Opsani. The reason I went to Opsani was they were really focused on a multi-cloud approach, and I knew that customers were aiming for multi-cloud, that they wanted to get away from having a single cloud vendor that they were beholden to. I knew that there were companies that were mixing on-premises, private cloud, and multiple public clouds in their application spaces. And I wanted to understand better how AI was going to intersect there. So I came back to Fortanix because I really didn't feel like the mission had been accomplished, right? The mission of delivering really data security and data privacy in the modern era, and especially as I came back, much more so around how AI needed to be secured. I think that'll end up weaving its way right into a discussion around zero trust.
Absolutely. So let's talk a little bit about Fortanix and confidential computing, because really what you guys have done is you guys are making confidential computing accessible, usable, manageable. Did I hit it kind of, is that right?
Yeah. You hit the nail on the head. So the genesis of the company really was the catalyst for the company getting started was Intel's bringing out software guard extensions, or SGX, as the marketplace knows it. And the reason why this was a critical point in the company's evolution was the founders were looking for a way to disaggregate security from the underlay. And even though SGX provides a hardware root of trust, the promise of SGX was if you had a workload that was running on an SGX enabled server, you could move that workload to any other server in the cloud or on premises that was running SGX anywhere in the world. And as long as you could then connect to the chip and have attestation, you could run that workload anywhere in the world on any cloud environment, as long as that SGX server was there and was available. And so SGX, with the combination of the hardware root of trust and the portability between clouds, enabled the team to start to build out security that would follow the workload. Right, that's what they ultimately wanted to do, was be able to attribute security policy and data privacy policy to the workload itself, no matter where that workload ended up, and maybe even as importantly, in whatever state that workload was in. And when we say state, we mean like a state of matter is either solid, liquid, gas. The state of data is either at rest, in motion, or in use. Right, and that was the other thing that SGX provided, besides portability of the security around the workload, was to protect the data while it is in use. So that then allowed for a strategy of being able to protect the data across all three parts of its life cycle, as well as wherever it might end up in the world and on any cloud.
Okay, I'm going to pick this apart a little bit, because you said something really cool that I don't think people will catch unless we kind of delve into it a little bit more. When we talk about zero trust, with the application space, it's all about trusting no one, verifying all the time, right? Yeah. And what we've done in the past is our security didn't follow the application around, right? I would have to have, if I moved it between clouds, I would have to have different security profiles for the different clouds to handle those applications. So the first thing you said I thought was fascinating, which is I can establish a security profile for an application, and it can live with that application now.
Yes.
By using SGX. So you guys have built a way of doing that. So I can attach security directly to an application regardless of where it's running. Did I hear that right?
You heard it exactly right. And really the way we achieve that is by utilizing the two key parts of confidential computing, which is a thing, right? A confidential computing isn't just a couple of words strung together. It's a real thing. It has an industry body called the Confidential Computing Consortium that both Intel and Fortanix are charter members of, and which establishes policy around what is and isn't confidential computing. And confidential computing really does require the memory encryption capabilities that SGX enable. But the two most important things about confidential computing, and I know that you know this, but all of your podcast audience may not, is the two most important things about confidential computing are isolation, meaning you've got to isolate the workload from the untrusted infrastructure, and that means the network, the cloud, the operating system, virtualization, and all that layer cake of stuff that sit below the application space in any server. You have to isolate the workload up in that memory in what we would think of as an encrypted box, right? That's encrypted on all six sides. And you want to put the workload and the application in that box. And once you do, then that box looks like a solid cube of encrypted bits to any bad guys. And they can't really do anything with it, right? But remember that it's isolated. The second thing that's important besides isolation is attestation, because you have to know that the user is the right user and authorized. You have to know where the workload is, where it is in the world, that it has the right software pieces, the right SGX, and all of those things. You have to know that you have multiple levels of attestation between the user, the workload, the cloud, the server, but when everything lines up, then that workload can execute, and it can execute completely securely. And so those two things, you said a few minutes ago about making confidential computing accessible. What we did was we built control planes that allow customers to manage their security and also allow them to orchestrate applications and manage workflows and things like that, so they can achieve zero trust for their data and also zero trust for their applications.
So I find this really interesting because you just mentioned some of the key principles of zero trust, without calling it zero trust.
Right.
The
Right.
attestation meaning I can identify who I'm running on. So I can
Hmm.
identify the device I'm running on. I can identify who's accessing me. That attestation part is critical. And then the isolation. I really like this as well because this really plays well into the whole concept that we hear about microsegmentation, but I'm not doing it just on the network. What you said was I can do
Yeah.
it in the CPU itself. So I can carve out a section of my CPU and memory that
Yes.
only people inside that microsegmentation or that enclave, we call
Yeah.
them secure enclaves, inside that secure enclave, only those things inside that secure enclave can access that data, the memory, right?
That's right.
Now,
Yep.
without this stuff, can someone get access to my memory? Let's say I'm running my application out on one of the cloud service providers.
Sure.
Is it not secure already there? I mean, the memory. What if everything else I've encrypted in transit in at rest? Why
Right.
do I
Right.
need to? Why do I need to encrypt it in memory? I mean,
Yeah.
who's going to
This,
access it?
this is a great this is the question actually, right? Is am I secure enough? And so without memory encryption, without confidential computing, the way that customers have tried to achieve security for those workloads that have to be decrypted and run in the clear, because that's the only way you're going to be able to manage encrypted data. You have to decrypt it and run it in the clear, right? If you want to apply code to it to manipulate it, i.e. an application, you have to decrypt it. Well, so think about that server is in the middle of a bunch of concentric circles. Let's call those circles like they're like moats, right? And those moats are
Okay.
zero trust architecture. So you've got the identity and access management moat, you've got the network moat, which could include northwest or north south firewalls and east west firewalls for microsegmentation, and it includes endpoint protection, endpoint security, right? So those three moats are the typical zero trust architecture. Well, what we've done, what you guys with SGX and now TDX and other technologies, and what we've done with our control plane technologies and actually microprocess technologies that run on the workload to allow you to open up that enclave. With those technologies, what we've done is we've created zero trust for data. So all those other areas are really important. So now, going back to your question about, have customers felt like they were safe enough with their application, their data in the clear, but with the moats of zero trust around them? Well, the fact of the matter is they didn't have any choice because that's all they had, right? If
Right.
they,
Right.
but with confidential computing, now they're able to add this memory encryption technology so that those applications and that data are encrypted in another place. And so bad guys can't use things like memory scrapes or man in the middle attacks or using social engineering to gain root password to the server, because all of those things are isolated away with confidential computing.
So what you just told me, I want to make sure I understand this. You just told me even if I have root access and I do a mem dump, I can't see. All I see is garbly
That's
in
all you
these
get.
secure enclaves.
That's right.
So it's a
That's right.
black box. So this is interesting because to me,
Sorry, Darren.
oh yeah, go ahead.
Even if you were to take that server out of that data center and X-ray the chip, all you would get would be that gobbledygook. That's it.
That's truly amazing. So what this tells me though, I almost want to coin a new term. Maybe we'll make a T-shirt out of it.
Let's do it.
Absolute zero trust.
I love that. That's actually great. Thank you.
There you go. Yeah, we coined it right here. You can buy the shirt. Go
I
to
love it.
go to our
That's
website. You're going to find the shirts on our website, embracingdigital.org.
That's right.
Who
We'll
knows?
call that merch. That's our merch.
Our merch. Yeah. So this is really cool because now here's my other big question then.
Yes.
What is the cost? Because anytime someone says, "Hey, encrypt everything," there's
Yeah.
cost involved. I'm not talking
Sure.
monetary costs. I'm talking time. We at
Yeah.
Intel have put a lot of encryption in the CPU itself now. So the overhead for encryption on data transit or at rest is minimal, less than 1%, less than 1/10 of 1% in most cases.
Sure.
What about though in use? is there a hit in performance, and
Yeah.
what is the trade-off that I'm dealing with here?
That's probably question number two. Question number one was the zero trust one. Question number two is what's my, what penalty do I pay if I pay one? And obviously encrypting anything and working with encrypted data forces some level of compromise, right? But here's the good news. You guys have worked really hard over the last 7 years to improve the overhead, to lessen the overhead for for applications and data that are running in trust execution environments or in enclaves. And I will go so far as to say Fortanix has been an active partner with you. I mean, we're probably your oldest
Oh yeah,
confidential
absolutely.
computing partner, and you guys ask us for help on performance profiling of new silicon and on side channel attacks and other things that we have a lot of expertise in this particular area together. And I would say certainly you guys at the absolute chip and hardware level, and us in terms of maybe helping with some of the profiling and other things, and at the software level, have gotten that overhead from, let's say, 30% was not unusual in 2017, 2018, down to a very comfortable single digits, maybe 6, 7, 8% max right now, and most of the time in the low single digits. So that's the penalty that you're gonna be willing to pay for absolute zero trust.
Okay, so that's interesting because not everything I do needs to be at that absolute zero trust, correct?
Correct.
Okay, so this is a trade-off I have to look at. If someone's processing, let's say, nuclear code algorithms, I want those at absolute zero trust,
Yeah. Well, the
right?
expense of the code, which in an AI environment is quite often some type of complex analytics, could be machine learning. These algorithms are expensive. They cost genomics companies millions of dollars to develop, and maybe to have one particular function to look for rare diseases or something like that
Right,
in a
right,
bunch of
right.
different workloads, right? Those things are expensive, and if you're running them in the clear and the bad guys get through the three moats, then they could memory scrape you, and then that could that you're going to have,
They
you
they
wouldn't
can
just have
get your
data
algorithm
loss.
then.
Yeah, they get your algorithm as well, right? So or they could inject bad code, which would give spurious results, and would destroy your experiment, and these things. In medical, but also in government, in intelligence environments, in financial services environments. These are all areas where the formula is critically important and expensive.
Okay, let's talk about what Fortanix brings to the table. I already mentioned
Yeah,
Fortanix brings to the table ease of use. Some of this technology that we talk about, SGX, kind of right out of the box, a little bit difficult to use. It requires rewriting code, it requires a whole
mhm,
bunch of other things.
yeah.
You guys have done something unique in this space. You've made it easy for someone to consume. Does it require a programmer to use, secure enclaves? What does Fortanix actually bring to the table to make it easy to use?
Yeah, it's a great question. So I am gonna uphold your point about there being guardrails, and which
Okay.
things that we and you have found out over the course of time, that SGX, because it's a bare metal technology, it's not virtualized. You're writing right to the metal, which means it's very, very secure because it's really hard to hack the chip, right? The flip side of it is it's not nearly as flexible as a software based solution where you can drop something into a VM. So therefore there are guardrails, right? And we've discovered these over time, and we and you have advised lots of customers. What we've tried to do to make it easy to get applications and data into the enclave is develop a secure SDK, secure software development kit, that we call Enclave Development Platform, EDP. It's open sourced. It's based on the Rust programming language, very, very secure programming language. It's one of, if not the most secure SDKs in the world. And our competitors use it since it's open source. We use it. We used it to build what we call Data Security Manager, which is our data security and data privacy platform for encryption and HSM functions and all of those kinds of data security requirements. But our SDK, Enclave Development Platform, can be used by anybody. And so a lot of our customers write applications in it. Do you have to be a programmer? Well, it probably helps to be a Rust programmer to use the EDP. That said, we also have developed quite a bit of tooling for confidential computing as it relates to applications that are housed in a control plane that we call Confidential Computing Manager. The Confidential Computing Manager runs on SGX. It is itself a zero trust platform that has a lot of capabilities around it, like quorum approval requirements, very strong role-based access control. So it also assumes a lack of trustworthiness among users and environments. But Confidential Computing Manager, Darren, has tooling in it like something we call App Analyzer, which allows us to take the logs from anybody's code and analyze them to see if that code would be able to go into an enclave without modification. And then if it is, we have another piece of tooling we call App Converter that wraps the application so that it can go into an enclave without having to make any modifications to it. The other thing the other thing the analyzer does is it tells you if your application, for example, may not go directly in. It requires maybe rewriting of some of the code with Python or something else that's enclave friendly. Sorry, didn't mean.
Oh, okay. So this is really important to me because I don't want to rewrite all my applications.
Yes.
So what you're telling me is I can take an application, analyze it. Yes, it can run in a secure enclave. Then I wrap it, drop it in a container, and boom, I'm off to the races. That's what I just heard. Is that so? How much time does that take me to? Does it take days to analyze my application? Hours? If my boss came to me today and said, Darren, you really need to run that in a secure enclave.
Yeah.
Can I say I can have that done by tomorrow, or is this like a week long type of thing?
No, usually by the next day. I mean, it's hours. Depends on the size of the logs and how many we have to run through.
Right,
But
and whether my application can do it or not.
yeah,
Right.
yeah, it's an hours long thing. Usually, we'll tell people by the next day whether or not they have issues with their app, and we probably can tell them what those issues are. Right. For example, as you know, as I know Java middleware doesn't and SGX don't like each other that much. It's not that it can't run, but it's that the startup time for any application that uses Java is very, very long. And so any kind of real-time services, it's almost, it's a significant trade-off. It doesn't make the actual running go slower. But what happens is that startup time takes quite a bit of time. So we've had a lot of customers come to us and say, here's our app. And we've analyzed it and said, you could rewrite this portion of the app in Python. Here's some scripting and then you'll be good to go. And we'll drop it in and we're good to go. So we try to also make that as painless as possible.
That's highly beneficial. Okay. This gives me some hope, especially on the application side. And I like how you've tied the zero trust application pillar with the identity pillar, because you've got access control and all that stuff. Where can this run? I know it can run on Intel chips, blah, blah, blah. But can I run this? We mentioned it running in multiple clouds. Is it available? Is this technology available just in my own data center on laptops? Where can I run this stuff?
Well, so there are two different brands of confidential computing. There's confidential computing for data, and there's confidential computing for applications, right?
Okay.
So confidential computing for data is represented by our platform that we call Data Security Manager, which runs on Intel SGX. And it replaces all of the traditional or legacy crypto functions like hardware security module. You don't need a specialized crypto chip anymore because we actually use the enclave. We use SGX to replace that specialized crypto chip, which means it's in software now. So we can do all kinds of cool stuff with it, like add encryption of data at rest and in motion. We can do global key management in the hundreds of millions of keys from one single console. We can do database encryption. We can manage keys for PKI and certificates, secrets management for the container space, All of these types of crypto, post-quantum crypto, all of these things are supported in Data Security Manager today. So that's the one side of the house. And that Data Security Manager runs, it runs on Intel SGX. So it either runs in an appliance that we've built, that we've gotten hardened and tamper-proofed with FIPS 140-2 level 3 certification, which is going to FIPS 140-3 level 3. So that's in motion right now. We use that appliance for on-premises environments, which are still about 50% of our customers are on premises, but it's rapidly moving to cloud. And the other 50% can consume us as a software download that runs on SGX in any cloud where SGX is present, which could be a cloud vendor besides the hyperscalers, or it could be Microsoft Azure, which offers confidential computing based on SGX around the world. It could be IBM Cloud. It could be a number of other cloud players that offer SGX. So we can run as a software download on any of those. And then the third instantiation is as a SaaS service that's available out of 17 data centers around the world, in all geographies, in fact. And in those data centers, we run them, we manage them, and it's on a global fabric. These data centers, we consume our own physical appliances in those data centers. So the service itself is actually FIPS 140-2 level 3 certified. So you can get a full cert HSM backed service for any of those crypto functions I mentioned anywhere in the world using our SaaS service. The workloads can run anywhere. They can be in your private cloud. They can be on premises. They can be in any of the second tier or hyperscaler clouds, and we can encrypt them and manage those encrypted entities from that one console, being consumed in any way that the customer wants to consume us. So that's confidential computing for data.
Right? What about confidential computing for applications?
So that's where we use Confidential Computing Manager, which also runs as a SaaS service and also runs on top of SGX. So it is itself, like Data Security Manager, is a zero trust service. And that and again, from a single console, you can manage your encrypted workloads running in an SGX environment. You can create workflows so that you can manage machine learning, or let's say a distributed application where you needed multiple enclaves to each one house a different part of the application that all need to be strung together. All that communication is managed by that control plane. And here's the interesting thing, Darren. The workloads, the application, the confidential computing for application workloads can execute anywhere in the world where there's an SGX environment. On premises, if someone buys their own servers, in a private cloud, in any public cloud where there's SGX, they can open up workloads, and Confidential Computing Manager will help them orchestrate the application.
So that's pretty cool. What you're saying is I can move my applications around.
Yes.
Right. On-prem, private cloud, public cloud. I can move those applications around and the security context goes with them. And I can, so this is pretty cool for managing these confidential computing enclaves that I have out there.
Yes.
It's highly valuable.
Well, I hope our customers see that. I think they do. I mean, we've got some really interesting customers doing very interesting things on confidential computing in different environments. For example, some that of, such as the Centers for Disease Control, utilizes confidential computing both for data and for applications. We have a shared customer as well in a company that spun out of University of California, San Francisco Medicine, UCSF Medicine, called Beekeeper AI, and their solution, has helped quite a few companies in the healthcare space that need to protect their healthcare AI algorithms and be able to move those algorithms to different workloads, different data sets in different places, because those workloads by compliance, we're not allowed to touch each other. So they in fact move the workloads around, and all of that's done with a confidential computing manager workflows and some of the other things that we've done. We've got a number of other customers, but those are a couple of good marquee ones.
That's great. Hey, Patrick, this has been wonderful. You really helped address a problem that we have in Zero Trust, which is the application side of things, and also data, right? Application and data. You really handled those two pillars really, really well. Thanks for explaining the concept and how we can protect our data even more. We need to have you come back on the show so we can just go over like some really cool use cases, because we haven't even touched the cool things we can do with confidential computing, like distributed collaborative analytics in secure enclaves, which I help architect some of that stuff with you guys.
Sure.
Really fun stuff. But we're out of time.
Love to do it again. Anytime, Darren, you can just ask me and I'll be happy to come on, and love to talk to your audience again at any time.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.